And I've noticed there's an orange dot there. Oh, Alejandro, that's quite okay that your mic's not working, but you'll want to get it fixed, especially before the test, which is on test 1 is on Tuesday, February 9th. I think you see that up here in the chat. Test 1 is on Tuesday, February 9th. You might want to jot that down, although we are going to go into ALEKS today and see where we can see where we're going to go see where we can see where the test date is in ALEKS. We'll do that about halfway through the class. So let's go down to my desktop here and let me make sure, yeah, the recording is on. So I want to go to right here to Adobe Acrobat. So objective 5, solving radical equations. That's what most of the material in this objective is about. So that's what I decided to call it. So we're going to start with a word problem. Feel free to ask lots of questions. So these T and then these numbers, those are really more for me than for you. That just stands for topic number 2 on the big packet of all the ALEKS objectives and topics that I have. Like I've got all 180 of them in one packet. So it's just a way for me to keep straight where we are in the course. So topic 2, solving a word problem using a quadratic equation with irrational roots. Irrational numbers are numbers that are not nice. Rational numbers are an integer over an integer. They're nice. They're nice. Okay, so wait a second. Let me back up. Rational numbers are nice numbers. Okay? They are an integer over an integer. An integer is -1, -2, -3, -4, -5, so forth, 0, 1, 2, 3, 4, 5, and so forth. So a rational root is a nice fraction. It has a nice number upstairs and a nice number downstairs. Irrational numbers could be like the square root of 2, the square root of 55. That's what we're talking about. Just numbers that aren't so nice. So a model rocket is launched with an initial upward velocity. That's, you can think speed, but when we talk about going vertical, we call it velocity. An initial upward velocity of 57 meters per second. The rocket's height, h, in meters after t seconds is given by the following. H equals 57t minus 5t squared. Find all values of t for which the rocket's height is 29 meters. Round your answer to the nearest hundredth. So this rocket is being launched off the ground, and it starts on this path, and at some point it's going to turn around and come back down. And what we're going to see is a parabolic shaped curve, really, like that. So chances are good, when it says to find all values of t for which the rocket's height is 29 meters, chances are very good that that rocket is going to go through 29 meters how many times? So let's see how many times it will go through 29 meters. So we're going to make the assumption that there's a line. Let's draw a line right here. And this is at 29 meters. So how many times does that rocket pass through 29 meters? It gets shot off the ground. So it's going through 29 meters once, goes around, goes through 29 meters like twice. So there's two answers here. So I think we've got, let's see where we go from here. So what we want to do is we want to find all values of t for which the height is 29 meters. Find all values of t for which the rocket's height is 29 meters. The rocket's height is given by this equation here. We're going to take this 29. This is the height, 29 meters. We're going to take this 29 right down here. And what we're really doing with it is plugging it in for h up here. Any questions on that? So what does that give us? That gives us 29 on the left side, right here, equals 57t minus 5t squared. 57t minus 5t squared. And we want to find, just to verify, what are we finding here? We want to find all values of t. We want to find the time, meaning we want to solve for t. So let's solve for t. So what we have here is a constant term. We've got a t term and a t squared term. So we have a quadratic equation. So we want to set it equal to 0, because whether we are going to use a quadratic formula or we're going to factor, we are required to have 0 on one side by itself. We're not fortunate enough to have a problem where we can take the square root of both sides, because we have a t term here. We have if you have a t or an x term, you cannot use the quadratic, you cannot use the square root. You cannot take the square root of both sides. So we're going to use the quadratic formula, but before we do that, we need to get everything on one side. And then although it is tempting to move the 29, that's not what we really want to do, because we want to look at this t squared term here, and we see it has a negative in front. So it's really best to move both of these to this side, so that we can keep this leading coefficient positive. If we move this to this side, that leading coefficient is going to be positive, and it won't make the quadratic formula as confusing. So the opposite of adding 57 is subtracting 57. The opposite of subtracting 5 is adding 5, and we'll do that to both sides. If we do that to both sides, we get 5t squared. We want to write in descending power order so that we are sure that we're identifying our a, b, and c correctly. So that's 5t squared. Then the t term, which is negative 57t, and then plus this 29. And that equals, these cancel, so we're left with 0 on this side. So we've got a quadratic equation set equal to 0. I'm not interested in trying to factor that. I would probably use the quadratic formula to do that myself. And so let's identify a, b, and c. A is 5. It's the coefficient of the squared term. It is 5. B is the coefficient of the t to the first term here, which is negative 57. C is 29. It's the constant. So we just plug in the numbers. So t here, we're solving for t here and not x, so I wrote t here equals negative b plus or minus the square root of this over 2a. So that's equal to negative, copy that down, b is negative 57 plus or minus square root. B is negative 57, put it in parentheses and square it. I always put this number in parentheses here so I don't forget to do it when I need to do it. So this is what we get for this problem, negative 57, and that is squared including the negative sign, minus 4 times A, which is 5, times C, which is 29, all over 2 times A, which is 5. So let's clean this up a bit. Negative of a negative is a positive 57, plus or minus square root. So negative 57 squared. I'm going to take my calculator and do negative 57 times negative 57. And I get 3249. I get this number right here. And then minus, got only one negative here, so this is going to be a minus sign here. I'm going to do 4 times 5 times 29. And I get 580. So now let's subtract these two. 3249 minus 580. And I get 2669, right, which is written right here. And then 2 times 5 is 10. So what do we have at this point? We've got 57, and let's just do the plus or minus, square root 2669 over 10. Now we really have two different solutions, so let's write them as two different, write this as two different solutions. 57 plus square root of 6669 over 10. I put parentheses here because anytime you've got two or more terms in numerator or denominator, you need to put the parentheses. Otherwise, the calculator is going to it's going to calculate something correctly. You just need to, in order to tell it to add the terms in the numerator first, you need to put parentheses around them because there are two or more. And over here, we're just going to do the same one over again with the minus sign in the middle. So let's just do the negative one. And I'll go in and use the calculator to do the negative one. So let's do parenthesis 57 minus square root 2669 over 10. And we want to round to, let me just see if I've got written down. I can see where we need to round. I just want to see if I wrote that down up here. I may not have. So we want to round to the nearest hundredth, let's say. It's one way to put it. And I'm going to write hundredth. So 2 places past the decimal point. So let's go to the home screen. Right now, I'm not in the home screen. I'm in y equals, so I want to go home. So I'm going to do a second quit here to go home. Now, I'm going to start with a parenthesis. 57 minus. Then we want a square root. So the square root is above this x squared. There's an x squared key in the first column here. There's a square root sign right above that. So and that on this calculator is in blue, that square root. So we need to do the second key first, second x squared. And that's going to put a square root there. 2, 6, 6, 9. Right arrow out from inside the square root, and then put a closing parenthesis there. Divided by, just a division sign, we'll do 10. 1, 0. Enter. And if we round to the nearest hundredth, we get 0.53, and this digit is 4 or less. Remember it, 4 or less, right? And so we just do the 0.53, and so the answer is 0.53 seconds. And that's how I got that. Now it has a little tip. Let me just show you what you can do to get the other number quickly. So what do we want to do? All we want to do to get the other number is to change this subtraction sign into an addition sign. So this blue, right down here above the red enter key, there's a blue word, it's entry. So if you want to repeat the entry that you just used, this is called the entry up here. You can then, since entry is in blue, I have to use the blue button first and then enter. And what I can do is use this left arrow key to move back over this subtraction sign and then just change that to an addition sign by clicking on plus. And then hit enter again, enter, and that will give us 10 point, and we're rounding to 2 decimal places, 10.86, but the next number is 5 or higher, so we have to bump this 6 to a 7. So we get 10.87. And let's just go back and check, 10.87. Any questions on this particular problem? So let's look at another one in this topic, and I'm not going to do the problem all the way through. I just want to point out something. This is the same topic, different question. Same exact topic, topic 2, and let me just verify topic 2, different question. A ball is thrown from a height of 123 feet with an initial downward velocity of 11 feet per second. The ball's height, h, in feet after t seconds is given by the following. So in this time, we don't have an object that's taken off from the ground. We have an object, the ball in this case, that is being thrown off the building. So how many times or how many answers are we going to have here? So what do we want to find? How long after the ball is thrown does it hit the ground? Well, this ball, after it's thrown off the building, is only going to hit the ground once. It's not going to hit it twice. It's only going to hit the ground once. So we only have one answer to find here. So we want to know how long after the ball is thrown does it hit the ground? What is the height on the ground? How far is the ball above the ground when it hits the ground? What is the height of the ball on the ground in relative to the ground?
123 feet.
No. So
0.
0. That's correct. So when the ball gets down to the ground, let me see if I can draw you a picture of this. I like it when you try though, because it shows me that you're thinking. I love that. You know, I mean, you can learn from thinking. There's no question about it. So when the ball is down here on the ground, when it's down here on the ground, how high, how far up is the ball up here when it's on the ground? Well, when it's on the ground, it's right here. So how far above the ground is it? Well, it's on the ground. So it's a height of 0 above the ground. And that's the reason for the 0 on this side. H is on this side all by itself. That's the reason for the 0 on this side. So you just put in 0 on this side equals, I wrote these numbers in descending power order. I wrote the squared term first, negative 16t squared to get started, minus 11t, that's the t term next, and then the constant, which is 123. Now what I did is I moved all of these to the other side because I noticed that we have a negative leading coefficient here. That's not good to work with that in the quadratic formula. It poses additional questions and now how to do it. It makes it more complicated. It's easier just to move all of this to the other side. So the opposite of negative 16t squared is positive 16t squared when it ends up on the other side. The opposite of negative 11t is positive 11t when it goes to the other side. The opposite of adding 23, adding 123 is subtracting 123. And then, when we add 0 to both sides, we're going to get 0 on this side. So I just moved all these terms to this side. That'll make using the quadratic formula easier for you. And when you do the quadratic formula, I'm not going to do all of these details in here, but I will show you that we get two possibilities for answers. We get 2.45 and negative 3.14. We're finding time. There's no way that time is going to be negative. So you can cross that out because of what T stands for in this problem. It stands for time. So there's no way that time's going to be negative, so you can cross that out. So your only answer is, in this case, for this problem, 2.45 is the time. And that time is in probably seconds, but let's see. That time is in seconds. Any questions on that? So I wanted to make sure I showed you the variant where I could illustrate what is the height of the ball when it's on the ground, above the ground. It is 0. The height is 0. When it's on the ground, whatever's on the ground has height 0 above the ground. Any questions on this particular topic? So let's take a look at this. This is a problem type that the college algebra coordinator at NWAC definitely wants us to go over. So let's take a look. So this is a process, and you might want to copy down some things about this process. But what you notice here, we're asked to solve y to the 4 minus 10y squared equals negative 9. This 4 here suggests that there are 4 different answers to this problem. There are 4 different solutions. And you will see there are 4 solutions here. 1, negative 1, 3, negative 3. We are going to convert it to a quadratic equation because we're used to solving quadratic equations. So let's see how that's done. I just took this equation, this quartic equation. Quartic means 4. The highest power is a 4. Took this quartic equation and just copied it down right here. And I see that there are 3 terms, so I'm going to try to get this. I'm going to do to this what I would do to a quadratic equation to get started. The opposite of subtracting 9, or the opposite of negative 9 is positive 9, so let's add positive 9 to both sides. What do we get? We get y to the 4th minus 10y squared plus this 9 equals negative 9 plus 9, which is 0. And if you feel free to unmute your mic and ask questions. So you want to make sure, you might want to write this down, right, in descending power order. And what we're going to do is we're going to do what we call a U substitution. I think we've seen one of these before. This just helps us put this equation in a form that we're used to solving. So we usually use u when we do this. Let u be the variable portion only of the middle term. The middle term, this is the middle term. This is the variable portion, just the y squared. It's the portion that has the variable in it. So you're going to see different variants of this problem, and you want to make sure it's the variable portion of the middle term. They're not all going to be y squared. So let u be the variable portion of the middle term, and the middle term is right here. Its variable portion is y squared. So what we're going to do, since we let u be equal to y squared, we're going to replace y squared with u. Well, what are we going to do with this one? We have to do something to that one. Well, if we take and square this, in other words, we take y squared and square it, a power raised to a power, you multiply the exponents, we're going to get 2 times 2, which is 4. We're going to get an exponent of 4. So after you find the u in this step, you want to take this right here, and to be clear, you want to take this right here. You want to square both sides of this, just to be really clear. So if we square u, we're going to get u squared. If we and I can go down, and we also, I wrote it up here as well. Now, if we square y squared, it's y squared in parentheses, all squared. Power raised to a power, we talked about that earlier in the course when we talked about exponents. Power raised to a power like this, multiply the exponents, 2 times 2 is 4. So we get y to the 4th on this side. And I boxed these in like this so I would know what to use when I get down here. So now we're going to convert. This y to the 4th is equal to u squared. So we're going to take out this y to the 4th and put u squared in its place because they are equal. So I put u squared in its place. And then we have minus 10. This y squared is equal, y squared is equal to u. So we're going to take out the y squared here, and we're going to put u in its place. So u goes where this y squared is, and that would be after the 10. So we get 10u. And then plus 9, we just write that down, equals 0. We just write that down. So when we factor this, I'm not going to take the time to go through that. When we factor this, I mean, we're looking for 2 numbers that multiply to give us 1 times 9 here and add to give us negative 10. Well, I guess I'll do it. 1 times 9 is 9. When we add these together, 1 plus 9 is 10. That's the number we want, but wrong sign. So what we do is we just change the signs. So this is positive 1, it becomes negative 1. This is positive 9, it becomes negative 9. If we add negative 1 plus negative 9, we get negative 10, which is indeed what we want. So we're going to put u in the first position here and here. We're going to put minus 1 here, and then the minus 9 here equals 0. Now what we are going to do is this. We are going to set this factor equal to 0 because it's these really represent a real number times a real number, and the only way we can get 0 is if one of the real numbers is 0. So we set them each equal to 0 separately. U minus 1 equals 0, u minus 9 equals 0. To solve for u, we're going to add 1 to both sides. And then that'll make this negative 1 go to the other side as positive 1. Here, we're going to add 9 to both sides. That'll just give us u on this side equals. This negative 9 is going over here as positive 9. Our original equation wasn't in terms of u. It was given to us in terms of y. So now we need to convert back to y. And how are we going to do that? So we've got u here and here. So we would like to just have something that has u on one side by itself of one of our rules here that we put in the boxes, in the rectangles. So we've got u equals y squared. So we can take each u and replace it by y squared. Each one of these u's and replace it by y squared. So we get y squared here equals 1. We get y squared equals 9. Just copy these 1s and 9s down. So we're talking about now needing to solve these little equations here. In other words, we need to solve y squared equals 1, and we need to solve y squared equals 9. So we've got these little equations that we need to solve right now. Y squared equals 1, and y squared equals 9. And I forgot my square up there. That looked a little funny. Okay, so how do we solve this? How do we solve these? What's the opposite of squaring? What's the opposite of squaring? Can anybody tell me what process is the opposite of squaring?
Square root.
Square root, exactly, square root. So we want to take the square root of these. I'll just get a different color here so we can do that. So we want to take the square root of both sides. And when we do that, we've got to put plus or minus on one of the sides. So I'm going to squeeze in a plus or minus here. Take the square root of this side. Squeeze in a plus or minus here, a little bit easier to do over here. And we have to take the square root of this side too. Square rooting undoes squaring. So this undoes this. So we're just left with a y there. So y equals plus or minus 1. You can see over here, y equals plus 1, which is 1. Y equals negative 1. And putting the commas where we need them. Here, this square root undoes this square. So we get y equals plus or minus, what's the square root of 9? What's the square root of 9? It is
3.
3. That's correct. So we get plus or minus 3 here. So we really have two solutions here. The plus 1 and the minus 1. So we've got plus 1, comma, minus 1, comma, and we have two solutions here, plus 3, comma, minus 3. And those are our 4 solutions. And we thought we might have 4 solutions because this is the highest power that appears on our polynomial, and that suggests that we need to account for 4 solutions. Any questions on this particular problem?
Yeah, how did you do the U part? That's the one I'm confused about the most. Everything else I get.
So you just pick a variable. So if you don't want to, I mean, this is too hard to factor in the form that it's given in. y to the fourth minus 10y squared plus 9 equals 0. It's too hard to factor that way, because how would we factor this, right? And some of the variants are going to be, this one might be, you might be okay with factoring. You can we do this a lot in math. If you think that you can always pick a letter and introduce a new variable if you're going to think that it's going to help you solve the problem. And typically when we do that, we use u. Now, I'm thinking to myself, gee, in my wildest dreams, I want to have, say, a u here. You could call it v or w, or usually mathematicians just use u in these kind of situations when we want to use another variable that we think might help us solve the problem more quickly and or more accurately. So here we can just, gee, if my wildest dreams, I want just to have not a square on the variable, but I just want to have, say, a u here. So you can let u be anything you want to in math. You can let any variable be anything you want to in math. So I want to see what's going to happen if I let u be this y squared here. This middle term. Let u be right here. Let u be the variable portion of the middle term. We could have used any letter of the alphabet. We could have used any letter of the Greek alphabet. We could have used whatever we wanted to, but we tend to use u when we do this. So you just take out the y squared, or you say, and replace it with u. Now we can't just redo that really without noting what we did, because we need to remember that we're going to have to convert back to y's at some point. So you just write it down. I'm going to let u be equal to y squared. That way, when we get to near the end of the problem, we know how to get back to the y's. We know what the relationship between this u is and this y is. So we can get back to writing our answers in terms of y. So you always want to use the middle term in this situation, because what happened when we squared the middle term, we got down here, we got to the fourth power. So are you understanding what I'm saying? So you just pick a variable. It could be your favorite variable if you want. It could be your favorite letter if you want. It can't be y though. We just typically use u. It makes solving the problem much easier than having to solve a fourth degree polynomial. Does that make sense?
Yes, a lot better. Thank you.
Okay, that's good. That's really good. And so if you just want to jot this down, let u be the variable portion of the middle term and then square both sides. So let u be the variable portion of the middle term is right here. Square both sides. Is what's happening right here. And I got to get that. I want to make sure I'm getting that out of the way there. Square both sides. So yeah, you square both sides right here. Square both sides right here. And then you're putting, that happened down here. I guess I don't need to do it. That happened, square both sides. That's what's going on right here. And then you just do power raised to a power to get this 4 here. Any other questions on this? I know it seems odd first if you've never seen it before we're using a u substitution. And let's take a look at another one because it is quite odd. Same topic, different problem. So I want to show you the variance that give you some idea of the variance you're going to see in the same topic in ALEKS. So this one, solve this. Now this equation, I copied down this right here, the plus sign, the 4, and this right here in parentheses. And then I just added the 4 to both sides. Add 4 and get 0. So we want u to be the variable portion of the middle term. This is the middle term right here, the one in the middle. Terms are added. The variable portion is y squared minus 3. If you have a string of terms here, in this situation, you will need to keep the string of terms. And in this case, that's y squared minus 3. Then we take u being y squared minus 3 here, and we're going to square both sides. This side's u squared is u squared. This side, y squared minus 3, is y squared minus 3 in parentheses squared. With that purple 2 there. And then we substitute. So that means we convert to u's. So what we're looking at this term here, we're looking at this, and let's see what we need to do. So we are going to y squared minus 3 squared is u squared. So this right here is this, including that square on the base there, including that 2. That whole thing, that whole first right here is equal to u squared. So I put a u squared under it. This, on the other hand, y squared minus 3 is this whole side right here, which is we've got equal to u. So I replaced it with u here, or we're going to replace it by u here. So what do we get? This is u squared plus 4. This in parentheses is our u plus 4 equals 0. So this is pretty easy to work with. So we're looking for 2 numbers that multiply to give us 1 times 4, which is 4, and add to give us this 4. So one way to break 4 down into its factors is 1 times 4. That is 4. But when we add 1 plus 4, we get 5, which is not 4. Another way we can break 4 down is 2 times 2. That's 4. 2 plus 2 is 4. So that's what we want. And so we are now going to write, since we have a understood leading coefficient of 1, we are going to write our factors like this. We're going to put u in the first position in each factor. And then we're going to put one of these 2's in plus, and it's a plus 2, it's positive 2, so we're going to put positive 2 here, and we're going to put this other positive 2 there, and that equals 0. So now we're going to solve. We're going to continue solving. So we want to set each factor equal to 0, but our factor is exactly the same. They're both u plus 2. So in this case, we only have to set one of them equal to 0 because we're going to get the same answer for both. U plus 2 equals 0. We're going to move the 2. So we're going to subtract 2 from both sides. That will give us just u on this side and give us u minus 2, or give us 0 minus 2 on this side, which is negative 2 on this side. So we've done all with the u we can. Our u has done us a lot of good, but now we have to get back to y's because our original equation is in terms of y. So u, how are u and y related is the question. U is equal to y squared minus 3. So take out the u, put in y squared minus 3 equals -2 and solve. So let's first deal with this -3 here, the opposite of subtracting, adding 3 to both sides. That gives us y squared minus 3 plus 3 is 0. Y squared plus 0 is still y squared. So that's all we get on that side, equals -2 plus 3 is 1. And just like in the previous problem, we're going to take square root of both sides, putting plus or minus with this side since we're solving for y. So square root undoes squaring there. We get y on this side equals plus or minus the square root of 1. The square root of 1 is 1. So we get plus or minus 1. So there's the plus 1, comma, the -1. So our answer, we just have two answers here, 1 and -1. They both occur twice in this problem, and that accounts for that we really have 2 raised to the 2, and I don't expect you to know this, but that accounts for the 4 solutions that we really need. Any questions on this? So this is the answer 1, comma, -1 that you would need to state in ALEKS if you got this exact problem. Unlikely that you're going to get that exact problem. Any questions on that? So we've really looked at a couple of tougher topics for sure. And then we'll do the Pythagorean theorem one, and then we'll probably take a break. I've got some announcements I want to talk about. So let's look at this using the Pythagorean theorem. So the Pythagorean theorem has to do with a right triangle. So we've got these two sides form this right angle right here. It's a 90-degree angle. And it's typical what we put on a 90-degree angle. And the legs form that 90-degree angle. So we've got this is called a leg on this side. This is called a leg on this side. The other side that's not involved in forming this right angle is called the hypotenuse. So this side is the leg, this side's the other leg. This opposite side from this right angle is the hypotenuse. And the Pythagorean theorem says, and let me label this, and to make sure I'm going to label this correctly for the problem. So that would be X. So this is going to be A on this side. This is side A in the Pythagorean theorem. That's side A. That's a crazy looking A. Let me try to get that a little better. It's really difficult to do curvy letters with this software here. Let me see if I can get it a little better. If I can go all the way around, I can usually get it. It's just a little bit difficult. So I'll make an O and then we'll do this. Okay, that's A. This is B. This is C in the Pythagorean theorem. A squared plus B squared equals C squared. In other words, this is the sum of the squares of the legs equals the hypotenuse squared. So let's take a look at what our problem is asking us to find. That was just the background. For this particular question, the hypotenuse of a right triangle is 10 inches long. The longer leg is 2 inches longer than the shorter leg. Find the side lengths of the triangle. The only side length they're giving us up here originally is this 10. That's the only one. This 6 and 8 were unknown. And we'll see how we get the 6 and the 8. So the first thing, since we know we were given that the hypotenuse is 10, I quickly drew a right triangle and put 10 on the next to the hypotenuse. So the first thing I did was this first statement here, the hypotenuse of a right triangle is 10 inches long. Drew a triangle, put 10 next to the hypotenuse. Then it says the longer leg is 2 inches longer than the shorter leg. Well, we don't know much, and we don't really know anything about the shorter leg, so let's call that X. So the shorter leg, let's call X. And I drew my triangle so you could clearly see that that's the shorter leg. The longer leg is 2 inches longer than the shorter leg. So we take the X, right? We take the X and we add 2. So the shorter leg, we are denoting by just X. And then to get the longer leg, we have to take that the length of the shorter leg, which is X, and add 2 to it. So the longer leg is X plus 2. That's how we're going to represent it for now. So we have our Pythagorean theorem right here. Definitely want to know that for the test. And how do we deal with this? We have if you want to look at it this way, if you understand it this way, that's great. But you could look at the A as 1 leg squared plus, you could look at this B as the other leg. You could look at this A squared as 1 of the legs squared, plus this B squared has the other leg squared, equals this C, which is the hypotenuse squared. So let's just plug in. Doesn't matter. Half of you could put one of the legs here and the other half could put the other leg here. It doesn't matter which leg you put in first because addition is commutative. So we're just going to put in this. We'll use the shorter leg first. We'll put it in first. If we put it into the Pythagorean theorem, we're going to have X. This is A, so A in this case is X, and we want to square it. So we're going to get X squared plus our other leg. Our other leg is this longer leg over here, which is X plus 2. That's our B, by the way. That's our B. So this is X plus 2 squared, with a plus sign in the middle, of course, equals the hypotenuse, which is 10. But we have a square on. Each one of the terms has a square on it. So how do we handle this? Well, we have an X squared here. Just copy it down. This is X plus 2 squared. This 2 means we have 2 of the base, X plus 2 multiplied together. We can FOIL that. X times X is X squared. The O in FOIL is X times 2, so that's 2X. And we have 2X in the inside here too, so that's 4X. 2 times 2 is 4. So we can take out X plus 2 squared over here and replace it by X squared plus 4X plus 4. equals 10 squared is just 100. So now let's go ahead and solve this. So we get x squared plus x squared, that's 2 of the same, so that's really 2x squared plus 4x plus 4 minus 100 is negative 96 equals 0. Let's continue to solve. So I just copied this down here on the next page exactly as you see it at the bottom of this page. Let's factor out. So we have this. This is 2 is even, 4 is even, 96 is even. Let's factor the 2 all the way out front to make our life easier. If we take this 2 out, we're just left with an x squared inside. 4 divided by 2 is 2x minus 96 divided by 2 is 48. So we get this equals 0. So really what you could do now, we're solving for x. We can ignore the 2 because you could really divide both sides by 2 here. Let me just show you this. You could divide both sides by 2 here. So we could divide this by 2. And we're going to divide this by 2. 2 divided by 2 is 1. 1 times what's left is what's left, which is x minus 6 times x plus 8. So these are going to cancel. You can cross them out if you want. But it's important to understand why you're crossing them out. 2 divided by 2 is 1. 1 times what's left is what's left on this side, which is x minus 6 times x plus 8. 0 divided by 2 is still 0. So we could just cross out this. Oh, I don't want that to happen. It's not too bad. So we could cross out this 0, this 2 rather here, because why does that want to do that? I think it's okay now. Let's cross out this 2. So really what we have left here is just x minus 6 times x plus 8 equals 0. So we can set each factor equal to 0. And we didn't talk about the factoring. I'm just going to skip it for now in the interest of time because we spent a lot of time in the class talking about factoring. So you want to factor what's inside here. So you'll get x minus 6 times x plus 8 if you do it correctly. And we're going to set, since we have 0 on this side by itself, and these dots, for whatever reason, they come up sometimes in the software, these dots right here. Okay. So we want to take a look. We want to solve each one of these. X minus 6 equals 0 and x plus 8 equals 0. Since that's the only way we're going to get 0 on this side, is if one of them is 0. And if we solve for x, we get, when we move this negative 6 to the other side, we just get x equals 6. When we move this 8 to the other side, we get x equals negative 8. We're talking about the lengths of sides of a triangle. They cannot be negative, so I crossed this one out. So x is equal to 6. So if we go back up, we found that x is equal to 6. X is the shorter leg that's up here. That turns out to be 6. The longer leg is x plus 2. We know that x is 6. So we put 6 in here. We get 6 plus 2, which is 8. Any questions on this particular problem? So there are the answers right there. Good. Well, let's take a breather for a bit and let's talk about, before we get into solving radical equations, let's talk a bit about the upcoming test. So first of all, test 1 is on Tuesday, February 9th. Test will appear at 10 a.m. on that day, and that means it will appear, and it will disappear at 4 p.m. So when I say disappear at 4 p.m., it truly will disappear at 4 p.m. So if you wait until 3:30 to start the test, it's going to kick you out at 4 o'clock, no matter what. So just be mindful of that. So I would recommend starting the test earlier rather than later, but I know we're all very busy, and so I wanted to give you a longer window to take the test in, even though our class is from 12 to 2. So I put two additional hours on each side. So that's when our test is. So let's first take a look in ALEKS. And I'll have to get to ALEKS over here. And I want to show you the calendar in ALEKS. It'll take a moment to get in there. And let me make sure I'm not showing anything I don't want you to see. I don't want you to see somebody else's information. So this is a Tuesday, Thursday class. And we want to go into class tools and student view. Enter student view. These 3 horizontal bars up here give us access to the main menu in ALEKS, and there's a lot on the main menu in ALEKS. So I'm going to click on this, and I'm going to go down here to the calendar. Click on the calendar. Now the calendar has different views. It has a week view, 2 weeks view, and a month view. I personally like the 2 weeks view. So you can see it gives you a bigger picture of what's going on for the next couple of weeks. So you can plan better. Now there's 2 parts to this. These icons you can click on if you have any confusion about what date something is due. So for example, today's January 28th. If I click on this, actually this one here, you can see, if I clicked on that icon here, you can see that chapter 1, quadratic equations, is due. Let me do that one more time. It's due today at 11:59 p.m. We're doing radical equations now. That's due Sunday, 11:59 p.m. And let's do that again. I'm not sure why that. So it tells you, this is interesting. They just put this in the fall. Opens after chapter 1 quadratic equations is complete, or tomorrow at 12 a.m. So it's telling you when it will open. And then you can do the same for this one. So really what you're talking about, and I think I can show this to you better over here. If we look over here, and maybe not, I think we'll find a place soon. But what you really want to do, like for February 4th, is February 4th is this strip all the way down. The objectives are up here. The assignments that I have created, like the test review, assignment on matrices later in the term are going to appear below here. But this is really February 4th all the way down. So the test review no credit, let's take a look at that. Let's click on that and see what it says. It opens February 5th, which you can see the icon is in the February 5th slice here, if you will. And it's due February 9th at 8 p.m. It's a little after the test, so if you want to work on it a little more after you take the test, you can. So let's go on here. So I want to see the next 2 weeks. I just click on this arrow. And you can see test review no credit continued. It's very, very important that you do that test 1 review no credit assignment. I will tell you why. We are going to have an ALEKS test 1 review objective. But if you didn't do a topic in ALEKS, you never got credit for a topic in ALEKS as being learned that's in that test 1 review objective, or there's multiple ones in that review objective, you will not see it come up again for you before the test. So this particular assignment has all 25 topics in it. This test 1 review no credit assignment. So you see up here in this strip, the test 1 review objective has 25 topics. So if you didn't learn some of those topics, you're not going to see them in that assignment. If you never learned them, you're not going to see them in that assignment. So you want to make sure you're doing this particular assignment down here instead, or do it in addition. Students who do both tend to do quite well on the test. Students who do this objective, which is required for points, this is no credit, but students who do this tend to do very well in the course. So if you do it all and you really write it, you're writing your solutions out as you go and all of that. So that is the leftover from the test review no credit. Here is the test right here. Click on this. So I'm giving you a test that I created. And then you see test 1 appears at 10 a.m. and disappears at 4 p.m. It's due February 9th at 4 p.m. So that means that's when the test is going to disappear and you won't see it. You have 2 hours. There are 17 questions. And it opens February 9th. I just wanted to make it clear to you when it opens and when it closes. So it opens February 9th at 10 a.m. and it closes, that is, disappears at 4 p.m. Any questions? So the calendar is a great place to go for due dates. So if you're unsure whether you've completed an assignment on time or whatever, you can go check the due date and say, oh yeah, I did all the topics in that assignment, whatever you want to use it for. So any questions on the calendar in ALEKS before we go into Canvas? So let's go into Canvas. So I'm just going to click out of this. I'm working on a project with my online students, so I want to save everything that's on the screen that has to do with student groups in Canvas. So let's go and get into your particular Canvas course. That would be right here. And let's take a look. Let's take a look at test 1 required written work topics. And we will talk more about this probably a little bit later today. And this is very important. So for test 1, test 2, test 3, I cannot do this for the comprehensive final. It would be in violation of departmental policy, and I'm not going to risk my job for it. So I wish I could, but I can't. But for the first 3 tests, I will give you the required written work topics. So you're going to see these 7 topics in the first 7, it has the first 7 questions on your test. So you know exactly which ones you have to write written work for that you're going to upload to Canvas. So here are the test 1 written work topics requiring detailed written work. And let me just go into the student view. Need to get so that you can see what it will look like to you. So we're going to go into the student view here. You want to click on announcements. This is only going to show you the most recent announcements. So to find all of them, you want to click on announcements. Required written work topics. Here are the test 1 written work topics requiring detailed written work. So if you are doing a problem in your factoring and you have a factoring program on your graphing calculator, you will need to show all the written work in between the statement of the problem and the answer. You will need to show all of the written work in between if it's a written work required problem, even if you're using your calculator to check your answer. So I just want to make that, I just really wanted to mention that. So we've got, and it's good to know now what these written work required problems are so you can pay extra close attention to them. Simplifying a quotient involving a sum or difference with a square root. We've already done that. There's a video that ASU, our Arizona State University. Do you have a question? I'm hearing some. Do you have a question? I think I hear a mic on. Somebody could turn the mic off unless they have a question. That would be great. Okay, thank you. So we've done this one before, for sure. Finding the roots of a quadratic equation with leading coefficient greater than 1. You can do that using the quadratic formula if you want to. These videos were made by Arizona State University, who has a very big global online freshman academy program that uses ALEKS. So these videos are quite good. You can see using the Pythagorean theorem, which we just did today. Solving quadratic equation with complex roots, which we did last class, I believe. Solving a rational equation that simplifies to linear, factorable quadratic denominator, which we've already done. We are going to do this one today, solving a radical equation that simplifies to a quadratic equation, and solving an equation that can be written in quadratic form. We just did that today. That was where we let u be equal to something. So I wanted to show you this today so you would be aware of it, so you would be focused on looking at what these topics are so that you can pay extra special attention and you have plenty of time to figure out what you're going to write down for your written work for such problems, so you can do well on the written work portion of the test. So there are 7 problems here. They are going to be worth 7 points apiece. That's 49 points of your grade out of 100 points on the test. The other 51 points will come from 10 ALEKS problems where you will just get the score ALEKS gives you on those 10 problems. On the written work problems, I will be grading them and marking them up a little bit in Canvas so you can see where you've made any errors, and hopefully you won't make any errors on these problems. So Anybody have any questions at this point? We're going to be talking more about the test. So I think what more I'm looking for here are questions on the written work problems, if there's something you don't understand about those. Each problem is 7 points. Yes?
So whenever we do the written problems, if we get the right steps but the wrong answer, will we still get points for them?
Yes, I'm
Okay.
looking for the process. Honestly, I don't really care about the answer.
Okay.
I'm really testing you on different steps of the process to see if you know how to do those processes, if that makes any sense. Because when you have multi-step problems, a faculty member can test you on multiple parts of the problem. Does that make sense?
Yes.
Good question. Any other questions before we move on? Okay, let's take a look at another announcement. Required proctored testing. Required for proctored testing. And this, I believe, was all in the course syllabus at the beginning of the semester, at least a good part of this, at least this bottom part here. So there will be other proctored testing announcements. I haven't put them all in yet. I'm just putting in a few at a time so as not to overwhelm all of us. So I will put this one in proctored testing violations and consequences later, and we'll talk about it probably on Tuesday of next week. So when it says see the Canvas announcement, we'll talk about that on Tuesday of next week. The only resources that you are allowed to use once each exam begins are the following. Using any other resources is considered a testing violation. See the syllabus for approved calculators. So one of the things you will be doing shortly before you take your test, like minutes before you take your test, is you will be taking a brief video of your environment and what resources you are using. So see the syllabus for approved calculators. I didn't require a graphing calculator for this course this semester because of COVID. So I wanted to keep the cost down to y'all. So please see the syllabus for approved calculators. You might want to have, if you happen to have a scientific calculator lying around, that's okay to use. So it's just be sure you check the syllabus, which is in Canvas. You can get to it right up here. You are allowed 5 blank sheets of 8.5 inch by 11 inch white paper, can be lined. I prefer it to be white because I want there to be contrast on it. If you're using blue paper and you're writing in blue pen, I really can't see the contrast. So, I really do want it to be white. It is okay to be lined. If you don't have lined paper lying around or white paper lying around, please pick something that is where you're writing on it, which has a lot of contrast. And when you upload your written work to Canvas, you will need to write darker than you usually do because the moment you upload a document, it shows lighter. The moment I scan in a document, it shows lighter. So I want to be able to read your written work. And it's really got to be neat because it is a bit hard to grade this way. It's not the way I usually have graded in my life. So it's a bit difficult to grade with markup tools and so forth. So you have 5 sheets of blank paper. One of these sheets of blank paper is you are allowed a copy of the Canvas announcement entitled, "How do I take my exam test?" So on one sheet of paper, you are allowed, one of the 5, you are allowed to copy down that announcement and use it during the test because it's going to tell you how to go through the process of how is the Lockdown browser downloaded. Now the Lockdown browser is downloaded very much behind the scenes. Respondents Monitor and Respondents Lockdown Browser are working seamlessly together. I don't usually have many issues with Respondents. I have more with MyLab Math, but their Respondents is doing a great job. But this will lead you through the process. This, how do I take my test, will tell you what you need to do, what you need to be prepared for. We will take, I believe, take a look at this in a few minutes here, the special announcement here. You're allowed to copy this down for your test. None of the other announcements are allowed. I want you to do this because I want you to understand what the steps are so that there's less stress on test day. Using any other Canvas announcements is considered a testing violation. Now I say pencil because you're now down to 4 sheets of blank paper. You want to make sure you have plenty of room to write out your written work required problems, and so you want to be able to erase. If you write in pen, you won't be able to erase. And you want to write pretty big so I can read it. So the following are required for Proctored's testing: high-speed internet connection. So what Respondents is going to do is they are going to take a video of you. So you'll need to have your video camera on. So you're going to need a high-speed internet connection for that. And that was in the syllabus. Close proximity to a router. I'm literally sitting 3 feet from the router where I am at right now. Webcam. That's so that they part of the taking a video of you. So you got to be in webcam view for that to happen. Functioning microphone, internal or external, and that must be on where I can hear what you're, if anybody were to walk into the room and I could hear what they say, you know, it's not necessarily a violation. If you've got a sick kiddo that comes in the room, I'm not going to call that a testing violation. I've got 2 girls at home, and I know how important, you know, my children are to me, and I would want them to come in if they started running a fever or something. So, you know, it's not that I'm looking for. I'm just saying it's important to have your mic on. It's required. Windows or Mac operating system, government issued photo ID. Please use the one that you uploaded to Canvas, because if you don't, for whatever reason, get a good picture of that government issued photo ID on test day, chances are pretty high that I can go to Canvas and then look at that same ID in Canvas, and then usually there's some identifying information like your license number or something that I can match without having to contact you and without having to slow down the return of the graded tests. And a one-time fee paid online to respondents immediately before you take your first exam. Major credit cards, debit cards, and PayPal are accepted. So you're only going to pay the fee of $10 one time the entire semester. That will have paid for the proctored testing for the first test, the second test, the third test, and the comprehensive final. Any questions on this announcement here? So let's go to another announcement and see what else I have in store for you here. Upload written work to Canvas for all exams. Let's take a look. See the Canvas announcement? Well, I'm just referring back to all of these. So we'll talk about the violations later. Each exam has 2 parts and will take place in ALEKS. Part 1, 49 parts. Oh, sorry, 49 points. We'll have 7 written work problems, each worth 7 points. We've already talked about that before. You are required to upload your detailed written work to Canvas for these problems using exactly 2 sheets of paper. You are required to do so within 15 minutes of submitting your exam. So you've got the first sheet of paper is for that special announcement you can have by your side when you take the test. The next 2 sheets are for your written work required problems. So you have 7 problems, and you can put 4 on the first page and 3 on the second page, and you've got a little bit of wiggle room there with since there are only 3 on the second page. So just make sure you're doing your problems in numerical order. Neatly show detailed written work for problems 1, 2, 3, and 4 in numerical order on the first sheet of paper using only one side of the paper. Be sure to write dark. You can only use one side of the paper. Otherwise, it shows through. I've tried it out I tested a lot of things this summer. Can tend to show through if the paper's too thin, especially. Neatly show detailed written work for problems 5, 6, and 7 in numerical order on the second sheet of paper. Be sure to write dark. Now I've got rubric information here. 2 points if the first step, including math notation, is correct. 4 points, this is for the written work problems, by the way. 2 points if the first step, including math notation, is correct. 4 points if about half the steps in math notation are correct. 6 points if almost all the steps in math notation are correct, and 7 points if all steps in math notation are correct. I really can't give you it's hard to write a specific rubric for each problem. So that's about how I do Indeed Grade. Uploading written work to Canvas. You are required to upload these 2 sheets within 15 minutes of submitting your exam. Submit sheets in order. For information on using your computer or smartphone to take a picture of your written work, this was in the material that you read at the beginning of the semester. I'm just referring to it here in case you need to refer to that documentation. To upload your 2 sheets of written work, do the following. Click on modules, click on upload exam written work here. Note, select the correct exam number. Probably that's not so important anymore, as I found out, because I can put a due date on it, and students can only get into one of those particular places. You know, there'll be one that says test 1 on it, and you would not be able to get into test 2, test 3, or the comprehensive final yet. So I'm making sure that I put safeguards as much as I can in place. Part 2, 51 points will have 10 problems. These problems will be graded by Alex. You will get the score that Alex gives you. You can use your last 2 sheets of blank paper for these problems. Do not upload these sheets. So for those last 10 problems, those last 2 sheets of paper are your scratch paper for those 10 problems. Any questions on this announcement?
So for the 15 minutes portion, we only have 15 minutes to do 7 problems.
No, that's 15 minutes to do to upload your written work once your 7 problems after you have submitted your test.
Okay.
So that's good to clarify that, I think. Any other questions? So I want to make sure that we're all understanding what we need to do here. Any other questions? Just looking
So how do you pay the proctored exam fee? Is it gonna alert you or something, or do you have to do it through NWAC, or?
No, you will do it directly to respondents a few minutes before you take your test. The first time only. So a few minutes before you take your first test, and you only do it before your first test. And you can use a credit card or you can use PayPal. Okay?
All right.
And I'll show you that part of it a little later. I don't know if it's going to come up today or not, but if it doesn't come up today, we'll go over it on Tuesday. Does that make sense? Does it make sense, Alejandro? Yes?
Yes, ma'am.
Okay, good. All right, let's go on to another one of these to see if there's any other ones that I want to talk about here. Announcements. Where to go for help? I just want to make sure you all know that this document is here. I think we went over this at the beginning of the semester. It's various resources that we have. And Alejandro is going to be working on some study groups too. So I think this is it for what I want to talk about with regarding the tests in this course today. So I'm going to leave the student view. Alejandro, did you get my two emails I sent you?
Where did you send them through? Canvas or
Canvas.
direct email? Canvas. Yes. Feel free to start a team.
Yes. I'm glad I looked up. You know, lots of people are using Zoom, but the problem is that's only 40 minutes. It's going to kick you out. You know, and I don't want you to have to pay for software to use. So I think, you know, if you're okay with the 40 minutes, but usually when that happens, you almost have to allow 10 minutes for people to arrive and then you're down to 30 minutes. Do you see what I'm saying?
Yeah.
Yeah, so I wanted to look it up to be clear on what plans Zoom has. Now, interestingly enough, I found out, you know, when was it? Back in December, as long as you only have one person you have the person that's conducting the Zoom meeting and you have one other person, you can do it for as long as you want, but you can only have one participant. So there are a lot of restrictions on Zoom when you really think about it. So let's make sure we're covering what we need to cover before I go off on a tangent. And let's take a look at solving a radical equation. So this is a little process that you probably want to write down. It's pretty straightforward. Solving a radical equation. So we're talking about an equation that has a square root in it. You want to get that radical by itself. How do we undo a square root? We do the opposite. That is, we square both sides. We solve the resulting equation. And then we check all possible solutions in the original equation. Sometimes squaring both sides will introduce what we call an extra or extraneous solution, which is not an actual solution. So it's important to check it in the original, that you check all possible solutions in the original equation. So let's take a look. Take a look at this one. Solve for u. Just copy the problem down right here. If you look at that, and we go back here. Let me just jot this down real fast. Isolate, rather than going back and forth, the radical. Isolate radical. Square both sides. Solve. Check. Isolate radical, square both sides, solve, and check. Oops. Got a lot of things going on in my brain here. Okay, so here's our problem. Step one is to isolate the radical, but you know it's already isolated. There's nothing out here. So we copy this down. Square root of u minus 13 equals 8. This radical is isolated, so we square both sides. I put this square u minus 13 in parentheses and squared it, and also squared the 8 up here to get 8 squared. Next step, solve. Squaring undoes square rooting, so we just get what's inside the square root, which is u minus 13. 8 squared is 8 times 8, which is 64. Now we're going to solve. So the opposite of subtracting 13, adding 13 to both sides. These cancel. We just get u on this side equals 4 plus 3 is 7. 6 plus 1 is 7. So we get u equals 77. Now that's not guaranteed to be a solution. We want to make sure we check it in the original equation. So here's our original equation. We're going to put 77 in for u. We get square root of 77 minus this 13. Turns out that that's square root of 64. And we want to know if that's equal to 8. Square root of 64 is indeed 8. 8 equals 8 is true. So that means this is indeed a solution. So u equals 77 is a solution. Everybody good? Just check it up here. So let's take a look at this one. Let me make sure I'm not doing, I've got to budget my time here. Let's look at this one. Now this one's a bit different because notice it doesn't have the radical isolated here. So I just copied it over. We want to isolate the radical, which means get the radical on one side by itself and nothing else. So we've got -1 here. We want to move that. The opposite is adding 1 to both sides. So we get 1 plus 1, which is 2. And on this side, the -1 plus 1 is 0, plus what's left is just what's left, with which is this square root. Next, we want to, the opposite of square rooting is squaring, so we want to square both sides. So we get 2 squared here, and then the square root in parentheses all squared. 2 times, this means we want 2 2's multiplied together, so 2 times 2 is 4. Squaring undoes square rooting, so we're just left with 4w minus 16. And we solve. Want to solve for w, so let's first move this minus 16. The opposite is adding 16 to both sides. 4 plus 16 is 20 equals 4w minus 16 plus 16 is 0. 4w plus 0 is still 4w. Now we want to solve for w. We want to, the opposite of multiplication, division, divide both sides by 4. 20 divided by 4 is 5. 4 divided by 4 is 1 times w is just w. So 5 equals w. We want to check in the original equation, in the one that was given at the very beginning. So we get, here's the original equation right here. We want to check it with w equal 5. So we want to take out w, put in 5, everything else is the same. So inside the square root, we have 4 times 5, which is 20, minus 16, which is 4. So we have square root of 4 here, copy down the negative, the -1, and then this one. So this is square root of 4 is 2, minus this one, and this is the same, copy down over here. So we get 1 on this side equals 2 minus 1, which is 1. We get a true statement. So that means that this is the solution, w equals 5. And that would just go up here, as they give, Alex gives you w equals, so all you have to do is put in that number, in this case 5. Take a look at this. Okay, let's take a look at this problem. I believe this one is a written work required problem. So this is a one definitely to pay attention to. So solve for y. Y plus 2 equals that. So we want to undo the square root, so we have to square both sides. So take y plus 2, put it in parentheses, and square it. Copy this down. Square root negative y plus 18 in parentheses, and square it. So squaring undoes square rooting. So I cross this out, crossed out the square root. This 2 tells us we have 2 of these y plus 2 multiplied together. And if we FOIL, we get y squared, 2y plus 2y, 2 times 2 times 2 is 4, plus 4, equals just what's in inside the radical here, negative y plus 18. So let's combine these like terms. 2 plus 2, that's 4y in the middle here. And then I copied that down, and that down, and this down. Get everything on one side. So let's move it to this side because it's got a nice y squared sitting out front with an understood leading coefficient of 1. The opposite of subtracting y, adding y. Opposite of adding 8, subtracting 8. Opposite of adding 18 is subtracting 18. And this, we're just going to get 0 on this side. You get y squared plus 4 here, 4 plus 1, which is 5y. And then there's going to be a minus 18 plus 4, which is minus 14. And when you do the factoring, you get down to y equals 2, y equals negative 7. So we want to check those in the original equation. So what does that original equation look like? Y plus 2 on this side. So y plus 2. So this would be 2 goes in for that y. Equals square root of negative y plus 18. Square root equals a square root of negative y, which is 2, plus 18. So we get 2 plus 2 is 4 on this side. We get negative 2 plus 18, which is 16. Its square root is 4. 4 equals 4 is true. If we do the same thing on this side, we put in negative 7 here, plus 2. We get equals square root of negative, but we have a negative 7 plus 18. We get negative 7 plus 2, which is negative 5. This is negative times a negative, which is 7 plus 7 plus 18, which is 25 inside. Square root of 25 is 5. Negative 5 does not equal 5, so this is false. So our only solution here is y equals 2. So only one solution here. Any questions on it, on this particular topic? So it's possible that you're probably going to get some of these questions, particularly in this topic, which only have one solution. So I'm looking for both of those checks on the test one. I'm looking for neat work too, work done neatly and presented well. Presentation skills in math are very important. If you work in the business world, if that's what your dream is, or wherever you work, presentation skills are they're in every profession, really, for the most part, almost every profession out there. So I think it's important. Let me see. So we did this. Now there's some other little problems here. Solve the following equation for D. What do we do first? I copied this down. We want to move the 3. Want to isolate, remember the first step is to isolate the radical. This is a radical. Isolate, get it by itself. So I don't know why I copied it down twice, but let's move the 3, the opposite of multiplying by 3, dividing both by 3. Divide both sides by 3. 3 divided by 3 is 1 times square root of d is square root of d. So we are now left with t divided by 3 equals square root of d. We've got the radical isolated. So we're going to square both sides. So we take this entire side, put it in parentheses, and then square it like that. Squaring undoes square rooting. So all we're left with inside is that d. And that is the answer right here. That's all there is to that. T over 3 squared equals d. Now let's take a look. I'm just going to talk about one of these because they're very, very similar. I've got this problem, and then we have another problem here. Let's look at one of them. Now, really, what they're going to give you is a formula, if you will, with a square root in it. I wrote down the formula right here. Just ignore what's underneath there. I don't know how that happened, and I need to erase all of those dots, but that's okay. So I just copied down the formula I saw in the problem. Went straight to the formula, copied it down. Now, what's important is you know what the D stands for and what the H stands for. So I found what the D stood for. D kilometers to the horizon. Okay, D kilometers to the horizon. So I wrote something about number of kilometers he could see to the horizon. And then I wanted to know what H stood for. So I looked for H. If a person's eye level is H meters above sea level, number of meters eye level is above sea level. Wrote it down. And I looked for the question. Suppose the person can see 15.3 kilometers to the horizon. Kilometers to the horizon. That's 15. So I'm going to put 15 in for D. Or 15.3, sorry, in for D. So I put it there. At that point, I know my H is my unknown. So then I just solve for H, just like we were doing. We already did a problem or two like this. So that's what we did. We want to divide both sides. We want to isolate the radical. So divide both sides by 3.6 to get that radical isolated over here. So we get 15.3 divided by 3.6 equals the square root of H. And all we have to do is the opposite of square rooting, which is squaring both sides. That just gives us H here. And if you put this in a calculator and figure out what this is equal to, you will get 18.1 if you round correctly. And it does, I'm just checking, sorry, I don't want to keep you over too long. There's a calculator here in ALEKS that you can use to figure this out. Okay, let me come up to you. So we've covered what we needed to cover today. I know I got a little involved in talking about the test, but I wanted to make sure that you all feel comfortable when test day rolls around and you don't have any of it, you get all your questions answered before then. So real quickly, I need to see if there are a couple of students here, and I think at this point, let me see. Emily's here, good. Is Honesty here? Let me see, Honesty, I don't see her, not here. And then I'm just turning the page, and Alejandro is here, I know. Okay, good. So have a nice weekend. You're welcome to stick around and chat with me. I've got office hours now in this same Teams meeting, so you can stick around, talk with me. That may also be a good time for Alejandro to meet with you. I don't know. And take care. Have a good weekend, and I'll see you on Tuesday.
Yeah, you
You're
can stick
welcome.
around and let me know what time you guys have available. Only a couple people emailed back.
Yeah, Alejandro, I think is asking you to stick around. If you want to participate in study groups, not to necessarily today, but I think he wants to just have just chat with you.
Did you get a popular time, Alejandro, from everybody that emailed you?
So not everybody emailed me back. Um,
The,
so
the few that you
those that want to participate, if you can just let me know. Like for example, what time can you or are you willing to study? Like in
like
the weekend and the
for me,
weekdays?
I was thinking that like a day after class would be really good.
Okay.
Especially while some of the stuff that we talked about, is fresh. If some of the students don't have other classes that day.
Yeah, yeah, that'd be good. Um, and I'm willing to do that. Yeah, that's good.
Like we could even choose it to be Tuesday or Thursday. It could be one day out of the week.
Yes. And for those that like have to work after class and do that stuff, we can do like a study group on Saturday. I'm pretty sure most people are kind of free on Saturday.
Okay, that's
That way, things are due on Sunday. So if you have any questions, we can all talk about it
okay.
or go over it.
So I can't do weekends because I work the whole entire weekend.
Right.
But I can do maybe after class for like an hour, but I have a class at 3.
Yeah. Yeah. That's
Weekdays
fine.
work best for me. Like
Like a
that's the
Friday.
best. Yeah, Fridays, yeah, Mondays and Fridays work best, but weekends I'm like busy.
Okay. Yeah. So I'm gonna go ahead and email out. So what I'm hearing, and some people emailed me personally. They said after class was a good time for them too, or like Friday or Saturday was an also popular day. Saturday, Friday, and after class. So I'll get back to you guys and let you guys know what day, like kind of make a schedule.
So can I want to say something, and after class would be good. You could do it right in this team, which would be good. And I have all my resources that I could pull out for you if I needed to. And I have this is my office hour actually, so I could get you what you ever need, what you need.
So you could join us.
Yes, I could.
Yeah, I think that would be a good idea. Then Alejandro, if we did maybe like a Tuesday after class, and then we could do two a week if people have time. Since there's so many of us that have different schedules. Those of us that would prefer during the week, we meet up on Tuesday, and if not, then you guys can set up a Saturday class for those that want it on the weekend.
Yes,
I
most
totally
likely
agree.
it's gonna be like a Tuesday after class, and for those other people, it's gonna be like a Friday, because I think that was Michelle or Emily. Emily, she said that she works on the weekends. A lot of people do that as well. So it's probably gonna be a Tuesday after class. So it's gonna be the most popular one, and a Friday anytime.
And Alejandro, I can usually join a Friday class if you would like me to, because I don't teach on Fridays in the class, remote classes.
Yeah, a lot of people don't have class on Friday, so yeah, that'd be great if you would do us that favor of joining us. I'll
Yep.
let you know probably like 2 or 3 hours ahead of time when we are planning to tune in, and most likely we're probably going to use the same teams, or I'll create a different breakout room. But
Yes,
yeah,
good.
that way everybody has access to it.
That is great for you to create a breakout room. I love that idea because I've been wanting to try them anyway. And also, that way you could come back to me. I would still be there in the team, but you would be in your breakout room, just, having your peer tutoring. And you could come back to me if you need a resource or something. You see what I'm saying? Like, do you have the
Yeah.
from day such and such that we just went over, like today, for example? Could you put
Hmm.
could we share those? Because I
Yeah.
can upload it to Teams for you.
Yes, and I feel like Stephanie made a great point. The material is still fresh, and most of us take a little. Well, I know I personally start things that I don't quite understand, so it'd be great to instead of slow you down in class and have you run out of time, ask you later, be like, hey, can you explain this further or more in depth?
We are all in this together.
Yes, I think it sounds good. I think we got a plan going.
Yeah, me too. Me too. I love
Okay,
it.
guys, I'm gonna send out an email probably later this afternoon or tomorrow for sure, and kind of give you guys a rough estimate of the schedule, and it's probably gonna be on Tuesday and Friday.
Okay, thanks, Alejandro. Sounds good.
No problem. Thank you.
Bye, Ms.
Alejandro, you can use the same Teams meeting for Friday too, so that'll be good. So people won't have to look around for another link.
Yes. Yeah.
Okay.
I'll get with you on how to make the breakout room. See if I need some kind of permission from you since you created the teams. But I'll get with you. I'll let you know.
And tomorrow I'm meeting with another colleague to look at the breakout rooms as it turns out. So we're good.
Okay, awesome. Yeah, because last semester for my Comp 1 class, we used like a different breakout room. We had an essay together as a class, and we made our own breakout room. So that was pretty handy. And anytime we can just switch back to the class and switch back to the room. And it was pretty cool.
That's good. Now I know better what we're going to use it for, so I'm happy.
Yes. Okay. I'll keep you posted. And like I said, I'll send out an email. I'll have you CC'd today. For sure, sometime today, and for sure tomorrow if I don't get it out today.
That's understandable. You've got a lot to do. So thank you so much.
All right. Thank you.
Have a nice weekend.
You too.
Bye.
Okay, sorry. I had a question about like the test, so I didn't want to interrupt while they were talking about everything else.
Mm-hmm.
Hold on, let me turn my camera on.
Sure.
Okay. Hi.
Hi.
So for the test, you said we could get 5 pieces of paper.
Yes.
So the first piece of paper is for us to write down like the announcements.
Well, there's one announcement that is going to lead you through there's steps before the test, and it's going to lead you through all of those and tell you what those are. Okay. So it leads you through the process of how you start the tests and all of that, so that I want to make sure you've got that by your side so that you have something to refer to if it doesn't make sense.
Okay. And then 2 other, so we get 5 sheets of paper. 2 is for like the 7 written
work
that we're turning into you.
Yes. 4 on the first page, 3 on the second page.
And then the next 2 is just like any scratch paper we might need during the test.
Yeah, exactly.
Okay. So can we have are we showing you at the beginning of in the camera that we have exactly 5 sheets? Like, could we use more if we needed to, or is it like?
I would just like to keep it to 5 sheets.
Okay.
Yeah, I think that'll be okay because you have on those last 2 sheets, you've got both sides of the page.
Okay. Okay. I'm all the gears are turning and I understand now. Okay.
Yeah.
I was like, what if you need more? Okay. I completely get it now.
Left that you have. So you've got like 4 sheets of paper basically because it's 2-sided, right? You've got, so you're really only talking about 2 or 3 problems per sheet then.
Okay. I get it now. Thank you.
It's a lot to get. You'd be surprised. It took a long time for me to figure all this out. I had to think about it a lot.
Okay. Thank you so much. Have a good weekend.
Oh, I love it. You seem so happy. So that's such a breath of fresh air. Yeah, you have a nice weekend too.
Thank you so much. Bye.
Bye.